Example 6 says use a graphing utility to graph x cubed minus 3x plus 2 on the interval of -2 to 2. And then part A, approximate local max and min and determine where the function is increasing and where it's decreasing. So our graphing utility is our calculator. So let's use our calculator here. So in place of y1, we are putting x cubed. And so you'll use this button here for your exponent. X cubed, notice I'm still in there, so I'm going to arrow over to get out of that exponent position. Minus 3x plus 2. It gives me my interval on where I want that interval. So I'm going to go -2 to 2, and they're talking about your x. So now I'm going to go over here to window, and I'm going to change my x min and max to -2 to 2. When I have a specific x min and max, after I change my window to match this, I then want to go to zoom 0. So when I go zoom 0 is zoom fit. So I'm going to click that, hit enter. And here is my graph. So what that did, if I go back to my window, it keeps my x min and max where they should be. And then the calculator picks the best y min and max to fit your graph. So I'm going to just roughly sketch this graph right here. And it looks like it goes something like something like that. So what I'm needing to do is find my max and find my min right here for part A. And then that will actually help me with part B as well. So to find the max and min, I need to go to calc. So I'm going to go second trace. And you have to pick the right one. If I want to find this max, I cannot hit min and find the min over here. You'll get the wrong answer. Same thing here. If you're finding this point here, you cannot select max to find this point here. So if I'm wanting to find this one first, I'm going to go to max, number 4, hit enter. Now it's going to walk you through this. It's going to want the left bound, which is talking about the left side of that. So let me find something here. If I know that this is my max, okay, or on my calculator, this right here is my max. I want to go somewhere over there to the left side, the left bound of that max. So I'm going to use my arrows here going left and right to go to the left side of my max. So my max is, about right here. If I go a little bit further, and you can go here, you can go up closer, you can go further down. It just needs to be somewhere in that area right there. So hit enter once you are to the left side of that max you are trying to find. And now it wants the right bound. Now be kind of careful with this. One, I want to go to the right side of where I think that max is. So my max is here. I want to go somewhere to the right, but you don't want to go past another local extrema. So I can't go way over here. I need to go somewhere in this interval of my graph. So I'll arrow over. My max is about right there. I'm going to keep going right here. But again, it can be anywhere in between this local max and this local min. So hit enter once you are to the right of it, but not past the other one. I have no idea what guess is, so just hit enter through it. And there is my max. Now, your calculator might say something different. This one's giving me -0.9999989, but what is that really, really close to? And that's -1. So I'm going to call this point here -1, 4. And your calculator might actually say -1, 4. I don't know why sometimes it gives you the whole number and sometimes it gives this to you, but if it gets really, really close to a number, just kind of go with it. So now we have to do that process again. I'm gonna go a little bit faster this time to get my local min. So I'm gonna go second, trace, and now I want minimum. So you can either arrow down or just hit 3. And now it's gonna walk you through it again. So left bound. If I am finding this min here, I need to go somewhere to the left of that min, but I don't want to go so far left that I go to the other side of this local extrema. So I need somewhere in between here. Anywhere works. Does not matter. So I'm going to go right around here. Hit enter. Now the right bound. I need to go to the right of this min. So somewhere over here. Anywhere over there. Enter. And I get kind of a weird number again, and I'm actually glad it happened. So if this happens to you, your calculator might actually tell you 1, 0. If it says something like this, again, this point 9999842 is really close to 1. This is in scientific notation. Let's write this down real quick. I have 7.5 times E, let's just do it this way, times 10 to the negative 12. When they have 7.5 e to the negative 12, that's scientific notation. That is 7.5 times 10 to the negative 12 power. This tells you to move this decimal this many times to the left because it's negative. So I would have to take my decimal and I'd have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times right here and put zeros all there. So this number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 0.11075. What is this number? Really, really close to 0. So when you get a number that is like this right here, that is basically 0. If you get a number e to any negative number, that is 0. And let's actually just see if I got closer to this, if I would get a more accurate answer. No, not really. So, I mean, I just did it again and I got a little bit of a different number, right? So it's a calculator. It's giving the best approximation. Okay, so I have my points. And now we can answer both A and B. A wants to know approximate any local min and max. So the local max, I'm going to put equals instead of is. The local max equals 4 when x equals negative 1. And the local min is 0 when x equals 1. Okay, now I need increasing and decreasing intervals. So my increasing interval is increasing here and here. That's where my y values are getting bigger as I go from left to right. So because we already know my y is increasing, we're talking about exits. So it does not go negative infinity to infinity. I have a start and I have a stop. My start is at -2 to -1. And from 1 to 2. So then where is this decreasing? Basically everywhere else, right? Decreasing is this middle portion. And that is happening from x's again, -1 to 1. That's where my y values are decreasing. -1 to 1. Now I have a note in my notes that MyMathLab might want brackets right here. So if you're confident in your answer, try putting brackets on these endpoints. I hate that. We're not supposed to put that on max and mins and on endpoints because I don't know what's happening at those. But MyMathLab, I have a note, wants brackets there in those answers. Okay, rewatch that video if you need to, and then I want you to pause this video and check your answer for number 7. I want you to do that by yourself. It does not come out to whole numbers like this, so round to 1 or 2 decimal places. MyMathLab will tell you how to round, but for us, let's just go to 2. Round to 2 decimal places. So pause this video, round to 2 decimal places, and then check your answers. All right, just a little bit of a checkpoint if you're needing any help with that graph. Let's go ahead and put this into our graph right here. We've got 6x cubed minus 12x plus 5. I'm going to go to window. I'm still on that interval of -2 to 2 for my x min and max. And if I just hit graph, we don't get everything in here we need because my window is wrong. So once you have in that window the x min and max, you need to make sure you hit that zoom 0. So zoom, either arrow down or just punch in 0. And now I get a much better graph. And if you even want to go in a little bit more here, let's try, went from -19 to 29. -19 to 29. Let's just try maybe -10 to, where did it go to? Oh, right here to 29. Let's just try 15 because that was way too big. Okay, so that's a little bit better of a graph for us. So make your window check mine. So if you're too zoomed in, you're not going to get those min and max points. So if we just use that zoom 0, that would have been fine. That graph gave me everything I needed. But to zoom in a little bit more, I'm going to change that y min to -10 and that y max to 15. So pause the video and now see if you can roughly sketch your graph, find your max and min, and then that will help you with part B, where your function's increasing and decreasing. Okay, I hope you had time to pause the video and check or try to do it on your own. So now let's check your answers. So here's the graph that we got, kind of roughly sketched it. I found my max was at -0.82, 11.3, and my min was at 0.82, -1.57. So the local max is at about, right? Because we rounded, is about 11.53 when x is about -0.82. And the local min is about -0.153 when x is roughly 0.82. So if you drew your sketch and found your max and min, now that tells you everything you need about your increasing and decreasing. I know it is increasing from -2 to -0.82. So that's here. Then it starts decreasing from -0.82 to 82. And then it finishes increasing from 0.82 to 2. Remember, MyMathLab might want brackets at that 2 and -2 at the endpoints. But we should not have those when we're talking about increasing and decreasing. So if you have any questions, please email me.